Right, now talking about noise and everything, sound, let's close that. But now we're coming to a specific type of sound called music, okay? How does it come about? How does physics explain music? Let's have a look at it. In its simplest form, music is said to be monotonic. The word mono means single or just one. So a sequence of single frequencies played one at a time. We'll call that music. So in that way, we've got that being monotonic because we have got just single frequency played one at a time. But in reality, we know that music is polytonic. Polytonic means you have got a mixture of different frequencies played at the same time, making a harmonious sound. In other words, the combination of those multiples of frequencies it's combined in a harmonious way, and it gives us music. Okay, I love music so much, so I understand exactly what this means. So frequencies, multiple frequencies, so you have got polytonic, multiple frequencies played together in a harmonious manner, and we get music. Now, the sound played at the same pitch and loudness, but from different instruments, they don't sound the same. Okay? It's the same pitch. Say one is playing a guitar, somebody else is playing a piano, or some other type of musical instrument, a flute or whatsoever. They are playing at the same pitch. But the sound that comes out, it's not the same when we hear it. Why? Because the quality of sound here, the quality of the note is not the same. So when we talk quality, this is what we're talking about. We're playing the same pitch, same frequency sound, but the sound is not sounding the same, and therefore the quality of these pitches, the quality of these notes are not the same. Okay. Music and noise. Can we differentiate between the two? The answer is yes, we can. How do we do that? Remember that with music, we're saying this is a mixture of different frequencies played together in a harmonious manner. All right? So, polytonic. But this polytonic is harmoniously put together. So it gives us what we call music. All right? On the other hand, we do have objects that vibrate with multiple frequencies, producing that sound. So they produce sound that is polytonic as well. But this sound or these frequencies are not related to each other, and therefore that means they are not harmonious with each other. And because they are not harmonious with each other, the sound produced by such objects or instruments is said to be noise. So the sound waves produced by such objects is called noise because these frequencies are not harmonious. These frequencies do not constitute music. Therefore, they constitute noise. Right. Standing waves and music. Musical instruments produce harmonious sound because they are able to produce what we call standing waves when the waves produced by a source or the instrument, by the source here we're referring to that instrument, interferes in a constructive manner with the reflected wave. Okay? With the reflected wave. Now, when we talk of stringed instruments, example of a stringed instrument, guitar. Okay? Constructive interference occurs when K times half lambda equals the length of that particular string. Okay, this we're talking stringed stringed instruments. Here, K represents the number of standing waves that are there. Lambda, we know this is the wavelength, okay? And L is the length of the string in that guitar. Next, if we want to look at how it works with this stringed instruments, say we've got a string there of a guitar like that. That's its rest position. Okay, when it is plucked, this is what happens. It goes up there, then the wave is reflected. So the bottom one is the reflected wave. Okay, now half the wavelength, remember, is that. But then if we proceed there, I'm just prolonged or protruded that, you would see that I can complete that wave there. So this is now the full wavelength. But what is this one here? This is half wavelength. And this is the length of the string. Okay, so number of standing waves here, it will be just one standing wave because we're looking at this one here. This is called a standing waves as it is completed like that. Okay, right, and then we will proceed with the other types of musical instruments, then move on to Doppler effect. See you in the next section.